the first ever space mission, which was going to the moon's south polar region. India's second lunar expedition, the Chandrayaan 2, developed by ISRO using 100% homegrown technology. The moon provides the best linkage to Earth's and solar system early history. So deeply understanding the moon could give answers to the many important questions. The lunar south polar region, where Chandrayaan 2 is going to land, remains in shadow more than the north pole of moon. So there is a strong possibility of presence of water. Let's see from the beginning how did ISRO develop the Chandrayaan 2 mission. In November 2007, Russian Federal Space Agency Roscosmos and ISRO signed an agreement to work together on Chandrayaan 2 project. ISRO would have the prime responsibility for orbiter and rover, while Roscosmos was to produce the lander. On 18 September 2008, Prime Minister Manmohan Singh approved the mission in Union Cabinet meeting. The design of spacecraft was completed in August 2009, with the scientists of both countries conducting a joint review. Although ISRO finalized the payloads for Chandrayaan 2 per schedule, but the mission was postponed because Russia was unable to develop the lander on time. Later, Roscosmos withdrew in the wake of failure of Phobos Grant mission to the Mars. Since the technical aspect connected with Phobos Grant mission were also used in the lunar projects. When Russia cited its inability to provide the lander even by 2015, India decided to develop lunar mission independently. After a little time, Chandrayaan 2 was completed in 2019. The Chandrayaan 2 mission consists of a launcher GSLV Mark III, orbiter, Vikram lander and the Pragyaan rover, all of which are developed in India. GSLV Mark III will carry Chandrayaan 2 to its designated orbit. This 3-stage vehicle is India's most powerful launcher to date, and it's capable of launching Photon class of satellites to the geosynchronous transfer orbit. The orbiter, weight over 2000 kg. It carries 8 scientific instruments that will collect data while revolving around the moon in the orbit of 100 km. The orbiter high-resolution camera will conduct the high-resolution observation of landing site prior to the separation of lander from the orbiter. The Vikram lander, named after Dr. Vikram A. Sarabhai, the father of Indian space program, it is designed to function for 1 lunar day, which is equivalent to 14 Earth days. The Vikram lander has the capability to communicate with Indian Deep Space Network near Bangalore, as well as with orbiter and rover Pragyaan. The lander is designed to execute a soft landing on the lunar surface. Rover Pragyaan. The Pragyaan rover is a 6-wheeled robotic rover which contains 2 payloads. It can travel up to 500 meters and leverages solar energy for its functioning. Pragyaan rover can only communicate with the lander Vikram. The objective of the mission is to demonstrate the soft landing on the moon's surface and do different experiments on the moon's surface, which will help us to know better about the moon's surface and composition and early history of the moon and the solar system, and also to find out the presence of water on the south polar region. The mission has an allocated cost of 978 crore rupees. The launch date was set to 15th July, but a technical snag was observed in launch vehicle system before an hour of launch time. So the launch was rescheduled on 22nd July. Chandrayaan 2 was ready to launch from second launch pad of Satish Dhawan Space Center at Sriharikota.
9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Liftoff normal.
R2 tracking.
3 tracking.
Tracking.
P2 tracking. P4 tracking.
ISRO successfully launched the Chandrayaan 2. After being placed into a parking orbit of 45,475 by 169 km by the launch vehicle, the Chandrayaan 2 spacecraft will gradually raise its orbit by using onboard propulsion over the next 22 days. In this phase, 1 perigee raising and 5 apogee raising burns will be performed to reach the highly eccentric orbit of 142,975 by 276 km. On 13th August, translunar injection was done. This will send Chandrayaan 2 towards the moon, where moon's gravity can capture it. After 29 days from its launch, the Chandrayaan 2 spacecraft entered lunar orbit on 20 August. After that, series of lunar-bound maneuvers were done to decrease the orbit of Chandrayaan 2. On 2nd September, Vikram was going to say goodbye to the orbiter. The Vikram lander was separated from the orbiter. After that, series of 2D orbit burns were used to decrease the orbit of Vikram. Today Vikram was going to soft land on the moon's surface. 2 landing sites were selected, each with a landing ellipse of 32 by 11 kilometers. The prime site is on a high plain between the 2 craters Manginus C and Simpelius N at a latitude of 70 degrees south. Vikram began its descent by using its onboard computers on Vikram, with the mission control unable to make corrections. In next 15 minutes, Vikram was about to land on the moon's surface. Everything was working fine as expected, but unfortunately the lander trajectory began to deviate at about 2.1 kilometers above the surface of moon. The final telemetry readings during ISRO's live stream show that Vikram final velocity was 58 meters per second at 330 meters above the surface, which is quite fast for lunar landing, instead of expected velocity of 2 meters per second. The crash was confirmed by ISRO chairman K. Sivan, stating that lander location was found and that must have been hard landing. Both ISRO and NASA attempted to communicate with the lander for about 2 weeks before the lunar night set in, but unable to communicate. The orbiter part of mission, with its 8 scientific instruments, remains operational and will continue its 7-year mission to study the moon. What do you think about ISRO Chandrayaan 2 mission? Let us know by writing in comment box.